Well, howdy there, Internet students. This is Mr. Hermanson again. If you are watching this video, then are hoping to retake Objective 4.2b. Okay, so go ahead and watch the video carefully, take notes, and finish up the problems. And when you're done with that, you can email me a picture of your work. All right, so in this first population, in this first problem, we're showing the population of seacrest growing. Now, just one quick reminder here, and make sure you have these notes. If a situation is growth, and it deals with the percent growth, you have to find that growth factor, you have to do 1 plus the rate. So if it's 15%, we would do 1 plus 0.15, which is 1.15. And you can see that that's the number we're multiplying by. So every time we multiply by 1.15, we get the next year's population. Okay? And then the expression for this, and expressions are always going to look like this. There's some starting amount times some factor, growth or decay factor, and then you're going to have x for the power, or whatever variable you're using. So in this case, our population is our starting population, which is 50,000. And then we're going to multiply by 1.15. And we're going to do that for however many years as our power. All right. Now, so if we want to actually find a population, then we just have to use however many years for our power. So for this one, the current population is 45,000, so we're going to start with that. We want it to go up by 2%. So remember that you add 1 plus whatever your rate is. The decimal for 2% is 0.02, so I'm going to do times 1.02, and then I'm going to do it to whatever power my years are. Okay, and then to get the answer, I'm just going to do that on my calculator. 45,000 times 1.02, and my power was 7. Okay, and since it's people, we're going to round that to the nearest whole number, so 51,691. All right. So you can go ahead and do those problems now. The other kind of situation is when you're doing exponential decay. Now the decay factor, let's call that DF or decay factor. If you're given a percent of decrease, the decay factor is going to be 1 minus the rate. So in this first problem, the value of Kate's car is decreasing by 12% per year. So the way you figure out the decay factor is you do 1 minus the decimal for 12%, which is 0.88. And you can see that we're multiplying by 0.88 for however many years the car is owned. So the expression, the value, is equal to the starting value, 28,995, times whatever the decay factor is. In this case, it's 0.88, and to the nth power, however many years. So, and the annual rate of decrease in the value of the car in this case is 12%. And you can figure that out by thinking about what number you would subtract from 100% to get 88%. Okay? So you can go ahead and finish those problems up. And so let's put it all together here. So we have a number of bats living in a nature preserve. There's 2,200 to start with. Well, that's going to be the number that you start with in your expression also. The population has been decreasing by 2.5% per year. So I'm going to do 1 minus the decimal for 2.5%, which is 0.025. If you forget how to do that, just divide 2.5 by 100 to get that decimal. and that equals 0.975. Okay, so I'm going to multiply by 0.975, and I'm going to do that to the power of however many years this is. We want to go from 1990 to 1997, so that would be 7 years. And so the population would be 2,200 times 0.975 to the 7th power. And remember, these are bats, so we're going to round it to the nearest whole bat. So 1,843 bats. All right, that should do it for you. If you've been paying attention to that video, you should be able to do those problems and get those sent to me as soon as possible, and we'll get you a retake. Good luck with that.